the whole thing we've been talking about functions. What?
They can get a piece.
We'll come up and get it. The whole time we've been talking about functions, we're really just playing with equations again, aren't we? Although we did get some things like how to make a parabola or how to make some of those others. We can use functions. A function is anything where... Define me a function. Yes, you guys were having the conversation. What's a function?
A function is... Scared me. Constant.
How do you guys define a function?
Anything that has the same output? Like has
Anything that has...
one output.
A single input has a single output, right? Can the outputs be the same for different inputs?
Yes.
But you can't put it in once and get a different answer. Now fix the screen that you destroyed back there.
I didn't. If this way he didn't.
He wasn't.
Okay, obviously I wasn't talking to you. You take the bottom and pull it out. There you go. Thank you. Okay, so a function. We're going to look at comparing functions. So, how would you compare a different function? How might you compare different... Huh? How might you compare... What tool do you guys have at your ability to compare two functions?
Calculator.
A calculator, but what are you using the calculator to do? Let's say I've got a function, and one function looks like this. Another function looks like this. How do I compare those two functions? Are they the same function? So, what would probably be the easiest way to compare them? What did we just write up on the board? An equation, right?
Yeah.
Did we not do y equals kx? If I had an equation for both these, could you compare those two equations to find out the difference in the slopes of the equation?
Yes, difference in y.
Would it be the easiest way you think you could compare them?
Probably not.
Yeah, it is a very good way. Now, let's talk about this, the two lines I drew. If you were going skiing, how many people in here can ski? Okay, your answers don't count. Right now. Raiden, they give you a pair of skis and you have a choice of two slopes. You have the green slope or the black slope. Which slope are you going down the first time you go?
Green.
Why?
Because it's less of a, like just...
What do we call that? We compare steepness. So the green slope is not steep, but it's also not flat. It's not steep. I can go down that slope and live. Now, who's the people who raise their hand? Lexi? Which slope are you going down, Lexi?
Green.
Really?
Yeah, blacks are scary.
All right, Will, you're going to say black no matter what. So what slope are you going down, Will?
Black.
Why?
It's more steeper.
Because you want to die. That is a hideously steep slope. At the bottom of that, there should be a ramp where you jump off in the air and you tuck your body in and do the flying like in the Olympics. That's a steep slope. So we can compare functions. We can compare functions by the steepness of their slope. Does that make sense? How do I tell if a slope is steeper than another slope?
You look down it.
Well, let's say this one here is about, let's say this one y equals 1x or y equals x. This one down here is about y equals 1/2 x. And I'm guessing right now. How do you tell which one of those, the steeper slope had what? What was the difference?
It's a full number.
It's a bigger number, isn't it?
Yeah.
How about if I had a slope and I said, congratulations, Chris. America needs you. You need to drive down this ski slope. The equation for the slope is y equals 24x.
He's almost going straight down.
He's like, well, I'm going to get to the bottom fast, but not alive. That's all right. The package is protected and secured.
Chris, I hope you have a
They don't care about you no more.
So
needs a parachute.
the bigger the number, the steeper the slope. Now, I prefer a slope for myself that's like y equals 1/8 x. I like bunny slopes.
I know.
I like slopes where 3-year-olds are passing me.
Yeah.
I like doing little wavy tails past me. Sorry, here I am, I'm going, but I'm not falling.
He sits there and rolls over.
As I roll over.
Yeah.
So,
you roll
we
over.
often, when we compare functions, we're going to compare things like the steepness of the function. We might describe other things about the function. One's linear, one's nonlinear. One's proportional, one's non-proportional. One's steeper than the other.
Much funner than the other.
Well, it depends. This is still a scary slope. The only person willing to do it is Will or Tell, and there's a couple of you going to throw your hands in the air, we know, because you're like, hey, watch this, and we all get our camera out. Because we're going to get 100 hits on this as you die going down the hill. Triple black diamond, watch him go.
No.
Okay, so let's look at a problem that deals with comparing functions. This one says Quentin is choosing between buying books at the bookstore or buying them online version for his tablet. Common college problem. The cost of Y dollars, that's the output, right? That's the total cost. That's what you get out of it. Of ordering books online for X books is f of x equals 6.95x plus 150. Why did they write f of x?
Because it's a function.
They told you right up front it is a function. F of x, what does that really mean in everything we've done here?
Y is equal.
Y. F of x is pretty much the same thing as writing y. And they gave an equation. So it's 6.95x plus 150. What's the x here? What does x equal?
Input.
In this equation, what would I input for x?
F.
Read back.
6.
Read back. It says the cost Y of dollars of ordering books online for X books. That's the number of books. So each book costs what? Now, what's the 150 over there? Tax or shipping cost or whatever it is. It's something that doesn't change, right?
What government wants to steal from you?
No, not necessarily.
All of them.
Here, Wesley, let's put you in a bookstore. Now, here's what, because he makes money. Wesley went to college for 4 years. He got a great degree.
Yeah, I'm smart.
He got a great degree in animal science, but what he learned in college was he can make a ton of money reselling college books. So people at the end of their semester, they often throw away their books. Wesley's like, cool, free book, free book, free book, and then he marks them up for like $40 each. And since they cost $100+ in the bookstore, people come to Wesley and buy his books. Soon, at the end of the semester, Lexi gets done with her semester. She paid a lot for these books. She turns them back over to Wesley, and he gives her half the price back. That's better than no price back, right? And then Wesley sells them the next year again.
For $40.
Wesley's making money, isn't he?
He's making more profit than.
So, but what's the 150 for Wesley? That's the cost of the plastic bag that he's giving you, or the cost of the box he's shipping it to you with, or whatever it takes for Wesley to, it's the cost of his brain thinking for that moment. That'll cost you $1.50. It's his fee up front. That's where he makes his money. Okay, so the cost of buying books at the bookstore is shown in the table. Which method is buying books is more expensive if Quentin wants to buy 6 books? So we want to know which method is most expensive. Well, the f of x is pretty easy, right? How can we solve how much that one will cost?
Math.
F of x equals, well, what's it say?
6.95x.
Well, what's x? 6. So times 6 plus 150. So how much are the books? If 6.95 times 6 plus 150. Whip out a calculator and start calculating. This is supposed to be times, not a minus. It's a terrible dot.
Ooh, can I say it? That's times.
6.95 times 6 plus $1.50. What you got, Wesley?
191.7.
That seems a little high.
$40.50.
$40.50.
That's not right.
That's not right either.
I got
I have it.
What do you got?
$43.20.
What is it? $43 and
20 cents.
20
I
cents.
did something wrong.
Yeah, my guess is you multiplied again or something. So $43.20.
I put 150, not 1.50.
Well, yeah, that definitely ups the price. I mean, your time is probably worth that, but this isn't necessarily your store. So let's look down the table here. We need 6. We can accomplish this 2 ways. We could go back. What is each book costing here? Well, let's find the difference in Y. What's the difference in Y here? 15 minus 750 is?
750.
So the difference in Y here. What's 2 minus 1?
1.
So I have Y over X, which is 7.50 over 1. This is a direct variation, isn't it? If you look, what's the difference between 2250 and 15?
750.
Each time it's up, right? I could actually do this 2 ways. I could do, what's the equation for this? Let's ask that. Gavin, what do you think? Is this proportional or non-proportional?
Proportional.
So what's the equation look like? Y equals,
Y equals mx plus v.
oh, that's so sad. Proportional, direct variation.
Oh, y equals kx.
Y equals kx. And we know what k is, don't we? So y equals 7.50x, right? And x is 6. So 7.50 times 6.
I don't want to do it. I had it wrong last time.
What you got, Ben?
45.
45 bucks.
Great job, Ben.
So which is more expensive? Is it more expensive online or at the bookstore? Bookstore. Guess he's going online, right?
I mean, unless you don't get them on time.
Well, online you get them instantly.
Well, they're not at your house where you're
They're ebooks. You don't know what an ebook is?
Nope. Oh, yeah, I do.
It's called on your computer.
You read it right on your computer.
I know.
Or you get the computer to read it to you,
Okay,
in your case.
you can do that.
Oh, okay.
It's fun.
That was unnecessary. I do that too.
I like stuff being read to me.
You can sit there and take a nap.
Yeah.
Okay.
That sounds
Having
cool.
been effectively 2 different people.
That makes me want to go to sleep.
I can't
This is a story called Before We Were.
Yeah.
That story is called Before We Were Yours. That's what I'm listening to because I listen to books online. You can get all this stuff in all this way. The great thing about ebooks, you guys, is you can have it read to you. Osmosis doesn't work, but it's worth a try. That's where you turn the book on and you go to sleep, and you hope in the morning that you magically just memorize everything in the book.
Is that really a thing?
No.
Oh.
When I went to language school, people would stick their language book under their pillow and hope. That's how some people studied for their tests. Hope that it absorbed through. It didn't work. So let's look at the second equation here. It says Jamal wants to buy a new game system that costs 200 bucks. 200 bucks is important, right? He does not have enough money to buy today. So he compares layaway plans at different stores. What's a layaway plan?
A long year, like a longer
You
time
can pay
plan.
it.
Pay it over time.
The difference between layaway and pay over time, you walk out of the store with the device. Layaway is they take the device off the shelf, they stick it in the back room, and when you finally paid for it, they give it to you.
So it's like a longer.
Layaways generally don't cost you, they might have a fee, but they don't cost you a ton of extra money in interest. Whereas take it home, they're going to charge you interest. Does that make sense? So Jamal's, he's a smart man. He's not paying it. So the plan for store A is shown on the graph. So here's his balance owed. How much does he still owe?
90. No? Never mind.
What is each of these tick marks?
100.
40. Why do you say 100?
20.
These are 20, right? So how come it says it costs 20 or 200, but he only is paying 100? What did he do?
Because that's his down payment.
He'd already down paid 100, right? So he's looking at this. So is this a proportional relationship?
Yes.
Does it start at 0?
No.
So this is definitely a case of y equals mx plus b, right? How do I get the slope of this line?
Rise over run.
Rise over run. Good man. So I'm going to find 2 points where the lines cross all 3 lines, the 2 grid lines and the other, and I'm going to get rise over run. So what's the rise? Is everyone keeping up, or am I going too fast? Now be careful. This is not 1 from this mark to this mark. It's 20.
Oh, I meant like 1 square.
And yeah, but you got to know what 1 square is. And what's the run between here and here?
2.
2, because it goes from 2 to 4, right? So rise over run is 20
Over 2.
over 2, right? And what does 20 over 2 equal? 10 over 1, and anything over 1 is? So y equals 10x. Now, is this line positive or negative? Is the rise to the left or rise to the right? So my 10 needs to be a negative 10x, right? Because I'm taking away money every week, hopefully. What did it start at? What was the starting point?
100.
So y equals negative 10x plus 100.
10 weeks. Pay it.
Yeah, pretty much 10 weeks, and it shows that. Now, store B requires an initial payment of $60. How much did he initially pay the first time? 100. And then weekly payments of $20 until the balance is paid off. So, honestly, I can use this graph over here since it's provided. I can do this a couple ways. I kind of like the graph thing because it's pretty easy. Okay? So, let's just use up the graph here. He said he initially paid $60. What was the cost of the thing? 200. What's 200 minus 60?
140.
So he starts up here, right, at 140. Got it? How much is it decreasing every week? So what's the slope?
20.
So this one is y equals negative 20x. And what's the starting point?
140.
Plus 140. Well, this is the great part. It asked me, the end question is which plan pays off soonest. So let's look. If I go y equals 20x, the easiest way to do this is go all the way down. And I like to go bigger numbers because I need 2 points to make a line, right? So I'm going to go all the way over here to 5 because I like 5. Actually, I'll go all the way to 6. How's that? What's 6 times 20?
160.
So, and it's a negative, right? What's negative 120 plus 140? So it's 6 weeks, all he owes is $20, right?
Yep.
Does that make sense? And then I draw the line. Does this line have arrows? Why doesn't it have arrows?
It's not going up or down. It
It's on
Yeah.
stays one price.
He's not, once he pays it off, he's not still paying. That would make him funny. So, which plan pays it off the fastest?
The green one.
Plan B, right? Store B. Which slope is the steepest? Store B. So we can compare functions by discussing how steep they are. And you guys do it all the day. If you buy bananas and they're 20 cents a pound at this store, and at the other store they're 15 cents a pound, who are you going to buy your bananas from?
Well, it depends if you got gas to go to the other store.
Sure.
Which one's
Oh,
closer?
then the other store.
You're going to buy them at the cheapest store.
Probably waste more gas starting there, though.
It depends.
That's what someone
But we buy lots of bananas, man. We're going to crank out multiple loaves of banana bread and sell them to our fellows at school.
You know, I'll go for the 25.
They're mean.
Which store's closer?
All right.
More expensive ones you can sell.